Hello, in this video I will show you some examples how to find area of a region between two curves. This is, very easy application of integrals. uh, but, I just go ahead to explain the idea, how to do that. Because we will repeat this idea when we need to study, volume of a solid region obtained by rotating or find arc length or find surface area. So I think if you understand this idea, that would be easier for you to solve those problems, okay? So here's the idea. Suppose I have two curves in here, f of x and g of x, okay? And we need to find area of the region on the interval a and b. So basically in this situation, we know that f of x is greater than or equal to g of x. So because the graph of f is above the graph of g, right? I can write the formula of the area equal to integral from a to b f of x minus g of x and dx. Why we have this integral? You see, first, so if we split this integral into two integrals, like integral from a to b f of x dx, this is the area of the region under f of x, under graph of f of x. I mean the big region, right? And if you write minus integral from a to b g of x dx, what is the second integral? The second integral basically is the area of this region. So you take the area of the big region, subtract by the area of the small one, so you get the area between two curves. Yeah, that is the meaning of this minus, okay? Why we need to discuss the difference. All right. So it's from calculus 1. We know that the main definition, the very beginning definition of definite integral is the area of the region under some curves, right? Given that that curve is above the x-axis. Let's consider some examples. So like, for example, we have we need to find the area of the region bounded by the graphs of y equal to x squared plus 2, y equal to negative x equal to 0, and x equal to 1. Okay, so now we have to make sure about the graph of the function first, of those functions, and we'll see how to find them, right? Let's graph them. X, y, o. So the graph of y equal to x squared plus 2. What's that? That is the graph of y equal to x squared and move off on 2 units, right? So I have 2 in here, and the graph looks like this. That is y equal to x squared plus 2. And then y equal to negative x. Where's that? Y equal to negative x is this. So I can write in here. Okay, this is y equal to negative x. X is from 0 to 1. 1's in here. So that is x equal to 1. So basically our region looks like this. You see. That is our region. So we need to find the area of this region. Okay. So you see, in this situation, the graph of this function is above the graph of this function, right? So we can use the formula right here to find the area. So I just write the area, but first I write since x squared plus 2 greater than or equal to negative x on 0 and 1, It says, yeah, the graph of this function is above the graph of this one. We have the area is equal to integral from 0 to 1. X squared plus 2 minus negative x dx. So minus negative x, minus g of x. So we can evaluate this integral easily using the power rule. So I have x squared in here. Minus with negative would be plus x plus 2 dx. And then we use the power rule. The power rule say, yeah, antiderivative of x to the n dx is xn plus 1 over n plus 1 plus c, right? So this is equal to antiderivative of, x squared is x cubed over 3, x is x squared over 2, and then 2 is 2x. And this evaluated from 0 to 1. I plug 0 and 1 into this function. I get, first we plug 1 into this, we get 1 over 3 plus 1 over 2 plus 2 minus, and then 0 over 3 plus 0 over 2 plus 2, 0. So this part is 0. This guy, we can, 1/3, we can write in 2, we can write 6 in here as common denominator. 2 plus 3 plus 6 in 12. So basically, the final answer is 17 over 6. So see, that's how we can solve an area problem. But in this situation, we know the graphs of two functions, right? Everything is good. So we know exactly one is above another. So we don't have any problem with choosing which one is bigger, which one is smaller. But in many situations, they don't give us the graph. So we have to figure it out which function is bigger, which function is smaller. I'm talking about the following situation. Let's consider the second example. Now when you have the following function, we need to find the graph of the region bounded by the graph of 3x cubed minus x squared minus 10x, and g of x is equal to negative x squared plus 2x. In this situation, we don't know the graphs of these two functions. So we have to graph them. We have to make sure, by the way, they don't give us the interval, right? Okay, let me write from here. Let's find the area of the region between two graphs and two graphs of this function. Okay, so make sure everything is clear. All right, so the first thing we need to do is to find the intersections of these graphs. Find intersections. In order to find intersection, we need to put them equal, right? We need to put them equal because, when the graphs are intersecting with each other, so the function values are the same. So we put them equal when we put them equal and solve for x, right? Let's put them equal. So we have 3x cubed minus x squared minus 10x equal to negative x squared plus 2x. Then let's group them together. So I have 3x cubed minus negative x squared. So I have negative x squared will be cancelled out. Minus 10x and then 2x. I bring 2x into this side. I get minus 12x. And this is equal to 0. So I can take 3x out, right? Because 3x is common. In here I have x squared minus 4 equal to 0. And then I have x equal to 0, or x squared minus 4 equal to 0. So this is done. For this equation, we write x squared equal to 4 and x equal to plus minus 2. So basically, two graphs intersect at 3 points. X equal to 0, x equal to plus minus 2. Alright, so we know. Let's graph them, right? 0, -2, and 2 in here. You know, in this situation, I even don't want to know the exact position of f and g. You know why? Because sometimes we say, yeah, we need to find intersections, right? Let's say, okay, but anyway, we may do that exactly. For example, we want to find the graph x squared minus plus 2x, right? What is x squared plus 2x? So x squared plus 2x looks like this. You know, something like that, right? And the graph of 3x cubed minus x squared, 3x cubed. So the behavior of 3x cubed, let me write here, 3x cubed, right? The behavior of this guy at negative infinity is, negative infinity. So you would guess the graph of this guy should look like, at negative infinity. So saying the intersect with this guy, at this guy, this guy, right? So we can write, yeah, it's something like this. And this is our region. And we need to find the area of these two regions. We have to pay attention. For example, on -2 and 0, if this is f, this is g, so in here, the g is greater than f. But in this region, f is greater than g. So when we apply the formula, let me go back to the formula, right? This formula, so we have to change the position of f and g on each interval. You see? Because here we have f is greater than or equal to g. So I write, yeah, from here, I can find the area of both regions is equal to integral from -2 to 0. And on -2 to 0, g is greater than or equal to f. So I have g minus f of x, right? dx. And on another interval, from 0 to 2, f is greater than g. So I have f of x minus g of x dx. And now we just substitute f and g into each integral, right? And solve them. Okay? So let's solve the first one. I'll solve the first one for you, okay? Let's solve the first one. I denote by I1, and this is I2, just integral 1, integral 2, okay? So let's solve I1. Integral -2 to 0. G of x, where's g of x? That is negative. Now g of x is 3x cubed minus x squared minus 10x minus f of x negative x squared plus 2x. Many students forget, using parentheses in here. That is very important because if you have minus in here and you forgot to use parentheses, you will get wrong in the second term in here. All right, so let's open parentheses and simplify them. Basically, we get -2 and 0, and here 3x cubed. Again, negative x squared plus x squared will be cancelled out, minus 10x plus 2x. So that is minus 12x dx. Again, we use the power rule. We get this integral. So antiderivative of 3x cubed is 3 over 4 x to the 4 minus antiderivative of this guy is 12 x squared over 2, right? And evaluated from -2 to 0. So we plug -2 and 0 into this function, we get 3 over 4 is 0 minus 12, 0 over 2 minus 3 over 4, negative 2, 2 to 4, minus 12. 12 with 2, I can write just 6, okay? I can write just 6. 6, negative 2 square. This is 0. So how about this guy? I write minus 3 over 4. Negative 2 to the 4 would be 16. Minus, here is 4. 4 and 8 is 24. So this is 8, negative 8. You know, negative 8 with negative 3, 4. I get just 6. And this is the area of the first region. And this guy is equal to 6. Similarly, you can find the second integral, okay? So I hope you can do that yourself. So, you know, this is very basic examples of this topic, how to find area of the region between two curves. But let's mention again, right? We need to figure out which function is bigger than another in each intervals. Otherwise, we may get a negative numbers, you know. And of course, you know, we can write, basically we can write this integral. Let me write this, right? This integral. I can write this sum as a single integral. And that looks like integral from negative 2 to 2. And here we use absolute of f of x minus g of x dx. But of course, in order to evaluate this integral, we need to remove absolute. And how to do that? So again, we need to consider which function is bigger than another, right? In each interval. So basically, that's what we have in here. All right. So I hope that this video is useful for you. And in the next video, I will show you how to use integrals to find volume of solid region. And we have two methods, this and shell. Okay, see you in the next video.